Good morning, Dave Kenworthy, and today we're talking about something that I consider to be extremely important. And you'll have to forgive me because this kind of thing, me doing presentations on YouTube and explaining how I believe the ancient mathematicians put together their models of circles, squares and diameters. It's not something that I've ever thought that I'd be doing. And you've got to bear with me a bit because this I believe this is so important that we understand this. And in particular that our mathematicians understand this. And this is coming from the work of Algernon Berryman in his book Historical Metrology. And it's on page 14. And this is so important because it explains why historical metrology is such a complex subject and why we can't get it. Because this relationship where the circumference is 10 when the perimeter of the inscribed square is 9, when variable pi and root 2 are used, is not what Berryman tells us. He says when the inscribed square is 9, the perimeter of the circle is 10, when pi is 22/7. And this is taking it much, much further because what we're finding is pi can be a variable and root 2 can be a variable, and this relationship will still remain a constant. And that's why any number of variations can appear when we look at the relationship between root 2 as a diameter and pi. And Berryman tells us that 20 root 2 divided by 9 is pi. So when root 2 is 99/70, it's giving pi as 22/7. But when root 2 is 140/99, it's giving root 2 as 2800/891. But when we use these versions in the circle, we find that we have to use this one, pi, with this version of root 2. These two yellow ones work together and these two blue ones work together. And they produce the same result. And they prove, when we use them, they prove in both instances that the inscribed square is 9 units and the perimeter is 10. So we're going to look at it. We're going to look at the ancient model and we're going to just consider it and understand that these ancient geometers understood that variables could be used in this model with a constant circumference. And that's putting these people somewhere else in terms of the way that they were thinking about their mathematics. So this is the ancient model of the inscribed square and diameter. And the circumference in this model is 40/9. And the diameter is root 2. And when the diameter of this inscribed square is root 2, the side of the square must be 1. And when that is 4, then if we're using 10/9, this must be 4.444 or 40/9, which it is in both instances that I'm going to show you. And the way we do it is the diameter that we use is root 2 and it's a variable. So the diameter is root 2 as 140/99 And that one we use with pi as 22 over 7, and we get this 40 over 9, 4.44 recurring. And the second version, pi is 2800 over 891, and root 2 is 99 over 70, and we get the same value, and the same value for the inscribed square. And I can show that this is what they were using at Stonehenge, because the perimeter, or the circumference of the Aubrey circle, is 13,200 megalithic inches. And when we divide that by 4.44, we get 2970. We divide that by 3, we get 990. And I've been saying all along that the design of the Aubrey circle is base 11, or actually base 99. And we can actually interpret it by using a different length of imperial foot than 12 inches. We should be using 11.88 inches. So anyway, it very simply dovetails into Tom's Aubrey circle. Now, what I'm saying about the ancients is they understood this term yin and yang. And I know that's a Chinese term, but the Chinese like things to be in balance. They like the circle to be balanced. They like both sides of the circle to be producing a nice balanced whole. And we can say that the balance is produced as 40 over 9 in this circle. And it's produced by the yin being the pi version of pi, and the yang being the diameter. And when yin pi is 22 over 7, yang diameter is 140 over 99, and that all multiplies out at an inscribed square as 4. And the same applies in this instance. We can see that it's all about balance, and this equals this, and these two are different, but they produce the same mathematical harmony. And then finally, we can produce the eclipse unit in this circle, because there's always one, and all we have to do is multiply by 3.3. So we multiply that by 3.3, we get the eclipse unit. We multiply that by 3.3, we get the eclipse unit. And it's all there. We're getting the eclipse unit because that's a constant. That's a constant. These are variables. And these are variables. So where does this take us in terms of the way that these people were thinking and the complexity of their mathematics? Because they know that they can use variable pi, they can use variable root 2, they can use them against each other to produce this balance. And they also knew that when they multiplied these two versions of pi together, they got this number, 9.87654321, that they recognised as 800 over 81. So that meant that they could have pi to the power 4 of 6400. Well, it's 800 times 800. And we've got plus 81. We've got 97.54611 as pi to the power 4. Now, 97.5 is more or less what we expect the inside circumference of the Sarsen circle to be. It's what metrologists are always looking for. Nobody knows what that is exactly. Tom didn't even try to work it out. But it could well be that that's what they were looking for when they designed the Sarsen circle. That might be what they were looking for as pi to the power 4, resolved down to a value between 97 and 98. So there's a lot to think about, but what is so nice about this is a proof. This is a proof that Berryman's given to us, and he explains it in his book. But it's so difficult to dig down and see what he's actually telling us, because nothing about what Berryman's written in his book is easy. But we're not involved in this because it's easy. We're involved in it because it's difficult. We want to find out what these people were doing. I don't want my ancient ancestors to be as stupid as our archaeologists are making out. I don't want us to be looking down on them as though that we are their intellectual superiors, because I really don't believe it, having read Tom's work. And I don't like the way that the archaeologists present their programs on TV, where they have these people dressed in bearskins shaking spears at the sun and threatening each other as though they're warlike people, when I'm pretty sure that they weren't. And I feel that this that I'm presenting now, even though I'm not the greatest presenter, if you dig into it and have a look at it, it balances perfectly. There's absolutely nothing wrong with this. So if you know anybody that's interested in this, get them to have a look at this, and get them to click on the website and say that they've visited it. I'd really appreciate it if you did that. So thank you very much.